The objective for circuit 1 was to use one switch to control one light and to use the remaining 3 switches, 2, 3, and 4, to control lights 2 and 3. Laying out our diagram, we've accomplished this as shown in our diagram. Switch 1 controls light 1, and switch 2, 3, and 4 allow the remaining 2 lights to be controlled from any position.
The objective for circuit 2 is to run a cooling and heating system for a house. So as you see in our diagram here, the light 2 simulates the heating system, and the light 1 simulates the cooling system. And the switch 1 runs as like a dead man switch, so neither heating nor cooling system will run. And on our circuit board over here, if the switch 1 is in the on position, you can neither heat or cool nor heat. And when switch 1 is in the off position, it allows you to cool the house. When switch 2 is in the on position, it allows you to heat the house in the winter.
The objective of circuit 3 is to use 2 start-stop push buttons to control lights 1 and 2 independently. Also integrating the big red button as an emergency stop button, and when it's hit and then released, that the motors will stay off and must be restarted manually. This is shown over here. Start and stop each motor independently, and then starting both using the big red button, you must manually go back in and restart motors 1 and 2.
The objective for circuit 4 is that light 1 has to start first before light 2 can start running, and light 2 cannot shut off, or light 2 has to shut off first before light 1 can shut off, and both are still connected to the big red button, as similar to circuit 3. So over here on the circuit board, motor 2 cannot start until motor 1 starts, and then motor 2 can start, and motor 1 cannot shut off until motor 2 shuts off. And they both are still connected to the big red button, which stops them, and they do not turn on until you manually turn them back on.
The objective of circuit 5 is to control 3 different lights from 3 different switches in a Jeopardy game style, such that whichever switch is turned on first will hold that light on no matter if they turn their switch off or any of the other light switches turn on. The only way to reset the switches is through our emergency stop button, and by turning that off and then back on, we're able to reset our lights. As shown over here, whichever of the 3 contestants turns their lights on first, the corresponding light up here will turn on. No one else's will affect it. The only way to reset is using our emergency stop button. It's also shown, no matter which lights turn on, that their corresponding light will turn on.
Alright, so the objective for circuit 6 is to have 2 motors, and motor 1 will turn on, and then 10 seconds later motor 2 will turn on, and then motor 2 will shut off, and 10 seconds later motor 1 will shut off, and they're also hooked up to the big red button, which kills it. So over here, you can scroll down here, show the bottom, so this is the whole layout of it. So we go over here on the circuit board, and you press the start button, motor 1 turns on. You wait about 10 seconds, and then motor 2 will turn on. Maybe. Alright, there's motor 2. So now we will turn it off, motor 2 will turn off, 10 seconds later motor 1 will shut off. As shown. Okay. And then when you turn it back on, this is a kill switch, you press this, it'll kill the motor, and it will not turn back on until you press the button again.
The objective of circuit 7 is to run a grain auger simulated by light 1, controlled by 2 separate paddles from different heights inside of a grain bin, simulated by switch 1 and switch 2. Coming over to our diagram, we have, this is our grain bin, and both paddles are closed. As we start to manually unload the grain bin from the bottom, the switch 1 paddle will open, and as the grain continues to empty, the switch 2 paddle will open. At this point, our motor, which is the grain auger simulated by light, will turn on and the grain bin will begin to fill. The bottom paddle will close first, and as it continues to fill, the top paddle will shut off. At this point, our light will turn off and the grain will be completely full. If, however, we do this in the wrong order and we turn off the light top one, our alarm goes off, or if we go vice versa and the bottom goes, an alarm will go off.
In circuit 8, similar to circuit 7, but using normally closed switches, here's the diagram. Then moving over to the switches. So once grain starts filling, it passes switch 1. The auger is on, indicated by the light. Once it passes switch 2, the auger shuts off. And once the grain starts to drop below switch 2, the light stays off. And once the grain passes switch 1 at the bottom, it turns the auger back on. Now, if this is done out of order, it'll set off the alarm indicating that something went wrong. Alright, looking at circuit 9, this is our diagram. We have switch 1, 2, and 3, and stops with all of them, and then switch 1 is controlling light 1, switch 2 is controlling light 2, switch 3 is controlling light 3. This is representing a scoreboard for a baseball game for balls and strikes, balls or strikes. So if you flip switch 1, that indicates 1 ball or 1 strike, either one. Then 2 and 3. If you want to reset, just hit the button, shuts them all off. Once it's reset, flip 1 strike, 2 strikes,